Okay, can everyone hear me? Great.
Yes.
Okay, so I don't know if you guys can see my camera. It looks like it's not working. I don't know why. But anyways, I'm not the one who's gonna talk today. I'm very pleased to introduce Dr. Ruiz Diaz on behalf of the AGSA Applied Stats in Programming Committee. And Dr. Ruiz Diaz is going to present a little bit about SAS, which is a statistical software that has been used a lot in industry and in academia. And even though people are starting to use R more commonly these days, R or Python, for example, there are still some tasks that are very good in SAS, like handling big data sets or adjusting some features of mixed models. So Dr. Ruiz Diaz is going to introduce us to the general features of SAS and show some examples with applied examples with real data. So.
Okay, thank you, Josefina.
Yeah.
Really appreciate the opportunity to visit with you about SAS. I know one thing that I like to do is to try and make this as practical as possible. Obviously, the best way to learn is ultimately to practice with your own data. I know we are recording this, but my intention is really not to make this a video tutorial by any means. I like to get as much interaction as possible. What I like to do is I'll share with you some files and we kind of gonna work together through these files and make sure everybody can run some basic analysis in SAS. If you have any issues as we go along, please stop and ask questions. That's gonna be the best way to learn, okay? And everybody's going to learn if we are sharing some of the questions or any issues that you see. Also, I think I'd like to rely a little bit on chat and just reactions, thumbs up if you can follow things. So if you're having any issues, please let me know. So I'll try to stop regularly and make sure we're getting feedback from everyone. We debate a little bit whether we should do this in person, and obviously in person is maybe better, but also there's some advantage of doing via Zoom. So we'll see how it goes. The other thing too is that we scheduled to do these 2 sessions today and tomorrow. I was thinking try and target something, stay within about an hour. I think we do have 1.5 hours, but if we try to target around an hour, and if we can extend a little bit, but I feel like if it's too long, then obviously we may not have keep the attention from everybody. Okay, so okay, you see that. Sure I'm sharing the right thing here, just a second. Okay, can you see a PowerPoint? Yes, no?
Yes, yes.
Okay. Let's see, here the chat, reactions. Okay. Very good. So first thing I wanted to, again, thank you to the agronomy graduate student for putting this kind of a workshop together. I think it's a great opportunity to learn and focus obviously specifically on the type of things we do in agronomy. And so that's what I like to do today. Just gonna share one example of one of my students' data and kind of go through that. And I agree with Josefina, we do have a lot more interest in R, and obviously it's a very powerful software. But also many of us, we learn Sass, and I think there's still a lot of value there as well. And especially for maybe some more practical things that we can do, I think there's quite a bit of value. I'm trying to learn R myself, but I keep kind of going back and forth between Sass and R. So the topics I like to discuss in the couple of days we have, one of the things, help sources and data formatting and import, getting the data into Sass. I think this is one of the first steps, and obviously want to make sure we're doing that right. In terms of help sources, I'm gonna show you some websites there, but nowadays there's so much information out there that I think is very easy to find information on different websites, discussion boards, and please take advantage of that. That's always my first suggestion, is that not try, more likely somebody done it already. Don't try to invent or try to come up with something yourself. It's very likely there's some examples out there. And that's pretty much for most softwares today. It's not longer needed to basically going back and looking at the manual or anything like that. I like to focus a little bit more on Anova, which is typically what we tend to do, more of the typical randomized complete block design, field experiments that we all do. So we'll start with that, touching a little bit on overview, general concepts, different procedures that we have in Sass, Prog GLM, Prog Mix, Prog Glick Mix. These are the ones that more likely you hear or maybe use in some of your statistic classes. And a few other things in terms of mean separation, which is often what we tend to accomplish when we're doing a simple analysis, Anova analysis. And again, we'll work on one example today or tomorrow, and then interpretation of the outputs. Okay, how do we read the outputs of Sass? That's obviously a key point. And depending on how things go, we may try to get to regressions maybe by tomorrow, or even if needed, I think we can easily extend and have another session next week or whenever we can do, and maybe focus a little bit more on specific analysis that maybe just some of you needed. I also talked a little bit with Josefina about the possibility of comparing outputs from Sass and R. I'm in particular interested in something like that because I understand Sass, and I also like to see how some of the results compare to R. And so I think if we can do that, that would be nice. And again, that may be a separate session in the future as well. Hey, comments or questions so far before we get into more? Okay, so this is one of the websites where you will find information that I typically like to use, which is just the user guide. And this is obviously all online. It used to be a big book that we have available, but there's no need for that anymore. And so again, you can Google this and you can find the user guide for Sass Stat. And obviously, again, Sass is a big software used for many uses. We focus specifically only on the stat component for the things we use. Okay, so like I mentioned, I like to discuss and focus a little bit more on Anova. And there are a few things that are, and this again, just basic review of statistics. Assuming that most of you are taking statistics now, I already took statistics, and obviously you're familiar with this. Some of the key requirements is normally distributed experimental errors, okay? And there are ways to test for this, and we'll look at that. Equal variance between treatments, and again, residual plots. There are ways also to test for these assumptions. And independence of samples. Obviously, this is the reason why we do randomization in the field as well, okay? And so these are key requirements for Anova. And the reason why I mentioned this is because whenever we run Anova, ideally we should be testing for these assumptions first and make sure we don't have any issues. If we do have some issues such as data is not normally distributed, then we need to look at other analysis. And we're going to look a little bit more into that. The last time we did this workshop a few years ago, we did have several students who were dealing with non-normal distributed data. A lot of that tends to be like runoff data from the field, for example. Usually it's not normally distributed. Gas emissions, like N2O emissions, for example, those tend to be log normal distribution, or just, again, it's not normally distributed. And so there are ways to do that. And we can see more about that as well. And again, if some of you suspect that you have some data that is not normally distributed, let's talk about it and see if we can look into that as well. Any comments or questions on this? Okay, just trying to make sure here I see all the reactions or chats. Okay. Okay, the other thing that's often a big question for us in agronomy is this question of fixed versus random effects. And this could be a little bit of controversy in this, and maybe a little bit open to interpretation, and that's okay. Well, I'll discuss that a little bit more here. But when we talk about fixed effects in a statistical model, we're basically assuming that the factors that we are looking into are fixed in advance of the experiment. Essentially, these are the treatments, okay? So this could be a rate of fertilizer, it could be a rotation, it could be anything that we're really trying to test in the field. These are fixed effects that we are putting out there. So, so again, this is one of the key factors, okay? And then there's a random effects models. In this case, we're not really interested in the average value of this factor, okay? So in the case of fixed effects, we usually want to know, okay, what is the average yield, or what is the yield of this treatment, okay? If for this rotation or this fertilizer rate, we are interested in that mean value. In the random effect, we are not really interested in that necessarily. And it's really meant to represent general population of all possible levels, okay? This could be a typical case where we have multiple locations, and I'm talking a lot of locations, not just 2 or 3 locations. Ideally, we want to have the more locations, obviously, the better, right? And so I usually like to see 25, 30 locations, if all possible. And if what this is telling us, and if we are taking location as a random effect, we are basically trying to extend the results of this analysis to the general region, basically the population of locations, for example, of Kansas, okay? So if we're having 30 locations across Kansas, we basically use location as a random effect in the model. We are trying to basically estimate what's going to be the average response of specific treatment across the entire state, right? And so that basically including soils, environments, and so on. And obviously, the more locations, the better, but we know that's very expensive in agronomy, okay? So that's one of the challenges. If you talk to some statisticians, they may say, 10 locations is not enough, 20 locations is not enough, even 30 or 40 locations is not enough. But some of you who work with projects, we have a lot that has a lot of locations, and obviously, it's a lot of work, okay? But ultimately, this is what we're trying to accomplish in agronomy. We're trying to come up with conclusions that's going to be applicable to farmers across a wide range of soils and environments, right? If I'm getting a result only for Manhattan, and I'm saying that this combination of fertilizer works very well in this soil in Kansas, in Manhattan, but may not work anywhere else in the state, well, that's not much value, right? If I'm going to the next county and I'm saying that result may not be valid, okay? So ultimately what we want is really to be able to project and and take these results to a wider range and obviously useful for farmers. So that's why I like obviously to use random as much as possible in some of the models. So these are the two concepts. But then we have a combination, which is truly what we end up having in agronomy, which is a mixed effects model, okay, where we basically have both. And this is where we have fixed treatments, again, maybe rates of nitrogen or phosphorus or certain rotation. These are fixed factors. And then we have random effects, which typically will tend to be multiple locations, or I also like to use blocks or reps as a random effects, okay? And why reps are going to be random? Because again, we are doing this replication and blocks to basically take care or represent the variability that we have in the area, okay? And again, there are some debate there. I know some people say, well, that should be fixed. And again, a lot of that may be subject to interpretation. And again, that's okay. But having random factors in many ways has more powerful because of the type of calculation we're doing. And again, in general, these mixed models basically are going to be the ones that we're going to be dealing with more regularly in our analysis. Any comments or questions so far on any of these? Thumbs up, everything okay? Thank you, Amber, and I saw a few others there. Okay. And again, ask questions. Otherwise, we'll stop short, and we're not gonna make much progress here because we need to make this as interactive as possible. And again, in some situations, very clear if the experiment is fixed or random, right? And like I mentioned before, again, in other situations, a lot of that may be depending on your point of view. And this is where I think it's important. You as a researcher, you need to make that decision, and that's okay. We're not here to follow recipes. I think you need to understand what is a random factor, what is a fixed factor, what's going to be, whether or not you're dealing with a mixed model. But again, some of these going to be completely subject to your interpretation. And because you are the expert on your experiment, and if you're telling me, if you can convince me that your blocks are fixed for whatever reason you have, well, that's okay. I can live with that. But we'll look at a little bit later some of the implications of that when it comes to the actual analysis. Just keep that in mind. Okay, so we have many possible situations for how to analyze the data in Sass, and these are maybe a good way to look at some of the main procedures we have in Sass. One of those factors is, again, I mentioned this earlier, whether the data is normal or non-normal. Again, typically, or yield data or tissue analysis, grain moisture, anything like that will tend to be normally distributed. But I also have some experiments in my program before where we're dealing with non-normal distributed data, again, runoff, nutrients, N2O emissions, that kind of things are very typical that are non-normal distributed data. What we've done in the past is that we typically convert the data before, and that could be logarithmic conversion or some type of conversion of the data before we do the analysis. That has been the approach in the past. However, like I say, nowadays we do have ways to do this analysis without the need to make any conversion to the data, okay? And then again, like I mentioned earlier, whether we are talking about fixed treatments and fixed blocks, or if we're talking about fixed treatments, random blocks, essentially a mixed effect, mixed model, okay? So those are two key components. Okay, let me stop there. I think there's a question. Okay, so yeah, and so the question is whether or not what should we use to make a decision in terms of the best model. And this is a pretty good question, because we're just talking about, fixed effects versus mixed model. And if we are not completely sure how we go about it, how we can make a decision. And yes, there are ways to compare different models, right? The Akaike information criterion, the AIC is one of the ways to do that, and I'll show you that in the output of Sass. And there are many other ways. We're getting to regression. R-square is one that we often use, right? And so those are ways to compare different models. However, I think to me that's important. I think it's important to use those, but in many ways, I think it's more important that you understand your experiment and your data, okay, rather than relying too much in these ways to compare different models. Sometimes that can be an issue, okay. And so I think it has a lot of value in some situations, but at the same time, we have to be careful not to rely on that too much and maybe misleading. Okay. Okay, so getting back to this, maybe the more basic procedure in Sass is going to be Prog GLM, and this has, until just recently, I was seeing that some classes in statistics still use Prog GLM, and I think it's okay. It's a very basic one, but I don't know what's the point, because we have better ones today. But basically, with Prog GLM, all we can do is simple linear model with fixed treatments. We are not able to include random factors in Prog GLM. Okay, so that's one issue right there. And so again, if we are saying that our blocks are going to be random, then that's not possible using Prog GLM. We are assuming that we're going to have blocks or replications that are going to be fixed if we decide to use GLM. Then the next one is Prog mix, which basically allow us to use fixed treatments and random blocks, random replications. Here's where we get into mixed models. Okay, we are able to include both. And obviously, we can, using Prog mix, we can do everything else that we do with GLM. So obviously, Prog mix is going to be a much powerful procedure. And again, this is where I'm saying that Prog GLM perhaps has not much value, because we can accomplish more with other procedures. Then there are other, when we get to this, all assuming normal distributed data. If we're getting to normal, there are I haven't used this very much. Prog gene mode, we basically allow us to use to feed non-normal distributed data. But again, it has to be fixed, all fixed. We are not able to include random factors here. And then Prog glin mix, which is the one that I typically use by default. You can basically do all of the other ones, whether the data is normal, non-normal, and whether you have random, fixed, or mixed models. All of that can be done with Prog glin mix. And so I typically just use Prog glin mix. And so today I'll just use that, and so in my opinion, again, I don't think there's need to use or learn the other ones if really there's no need for that. So we'll just work with the Prog glin mix today. Okay, any comments, questions on this? Okay. So what I'd like to do is then I'll share a few files, and then we'll start working on some examples. Okay, just share with you one Excel file, which is a part of data collected by one of my students, Diego Charbonnier. He just graduated last fall. And let me see, I think I didn't share with everyone. Make sure. Okay. Are you all getting this Excel file? Okay. So let me see. I'm just gonna share these and so this is the data that I just sent it to you. It's an experiment with multiple locations. And actually this just part, this only 4 locations, but he ended up with 10 locations of this experiment. I'm just sharing part of these for this practice. Has 4 replications, okay? And the treatments is basically potassium rates in kilos per hectare. We have 4 rates, okay? And then the response variable is potassium in the tissue, okay? So this is potassium in %. So that's basically what we have there. It's just a quick pivot table just to look at what we have there. The data looks all complete. We didn't have any issues here, but we can actually talk a little bit more about missing data and things like that, which is obviously not uncommon. Somebody forget about getting the sample back from the field or something happened in the lab and we have missing data, which is again very common actually for us in agronomy. And so anyways, any comments on this data? Yeah, very straightforward, very simple. Okay, I'll share with you another Sass file. And one question, I'm just making the assumption that you all already have Sass in your computer. Anyone that don't have Sass still installed, although we need to quickly go through that. Okay, so I assume everybody have Sass and it's working well, your computer. Okay, okay, so I'll share with you another file here. This is a Sass file. That basically has the data already included there. Can you all see my screen? Good, thank you. Okay, is everyone able to open the file? Thumbs up. If I don't see any reaction from you, I will assume that you're not able to open. Okay, so most people are not able to open yet. want to make sure we are not missing anybody here. Brian, are you able to open the file? Maybe Brian is not even there.
I'm here. I hit the thumbs up thing. I couldn't tell if it
Okay.
went or not.
Okay, is anybody not able to open the file? Please. Because this is actually an opportunity to learn. If we're having issues opening or something, then this is the chance.
Hello. Yeah, I am not able to open because I have access to SAS Studio. So can you
Okay.
please send it in a document form or like a text file? Because it is in
That-
SAS file.
Sachin, you can upload that Sass file to Sass Studio.
Yeah,
will run.
actually, I tried to drag it, but it is not able to, it is not allowing to me drag to SAS Studio.
You should be able to, if you click on your folder
Uh-huh.
and then actually upload, click on
Okay.
upload to
Okay,
Sass
then it
Studio,
will
it
work.
should work, because that's what I'm doing.
Okay, okay. Thank you, Logan.
Logan, you may actually, are you able to share your screen and open and share that? Because I don't use the Sass Studio, and that may be what most of you have.
Unfortunately, I am actually working on two screens that are not connected, and so I have it brought up on my other computer.
Okay.
So I can't share it as it is right now, but for folks that took Stat 705 and used Sass for it, today sometimes they use R. If you use Sass for 705, you should have access to Sass Studio for academics. And you can upload this Sass file and run it as it is. It should be just fine. So, but you need to go through the steps and select your folder, go in, select upload, and make sure you upload the Sass file. And then you should be able to run it.
What if I share this just as a text also? Can you copy paste that?
That would be a good alternative for people that are having trouble uploading the Sass file as it is. Open it as a text file, which you should be able to do, like Notebook or some sort of file viewer on your computer. And then you can just highlight it and copy and paste it right into Sass Studio, and you're ready to go again. So that would
Yes.
certainly work as well.
Yep,
There you
that
go.
would be-
Perfect.
Yep, here we go.
Just put the whole thing in the chat in case that's easier. And I think we had this issue last time, is that some people were not. I'm not using Sass Studio, and I think Sass Studio has a few more steps.
A quick warning to people using Sass Studio, this is tab delimited. And so you're going to have to make the tab spaces. Otherwise, Sass Studio is not going to be able to interpret the tabs. So if you notice that run at the end of the data lines, the run is not highlighted in Sass Studio. That's because it's not, they're tabs that are separating the columns, not spaces. But that's an easy fix.
Okay. Okay, or anyone else are able to run this already in Sass Studio, whatever version you have. Yeah, see, Gustavo, thumbs up. Seems to be running. Sofina, okay. Jean, thank you. Okay, so this is again the same data. A few very basic things in the lines that we have here. We're basically giving the data basically we are putting a name to the data set. In this case, I just call it all data. You can put whatever name you want. Typically, one of the challenges here is I have to try to keep the name somewhat short. Oftentimes, I think there's a limit in characters. I believe is 10 or 12, I believe it is. But somewhere at some point when the name of the data is too long, you have issues. And this is where Sass can be a little bit tricky, and some people get frustrated is because you may see some errors, some issues. It's not really clear what's happening. One of the things I often see, and even to me often happen, is that I put names that are too long for my data, and that Sass will not take that. There's a way to modify that. If you really want to use a long name, you can do that, but it's just easier to use a short name. And so we don't need to get into that. And then we have 4 columns, 4 variables. This is basically your input line here, okay? And so in this input, we are indicating which are going to be the variables that we're going to have in the data. The first one is location. You notice this $sign next to it, and this basically indicating that we are talking about basically a text variable. It's not number. It's not a number. Okay, and so anytime you have something that's going to be text or a variable that is not numeric, then you need to add this $sign at the end. Then the next one is rep. You can also, again, you can change the name. You can use any name you want here. This is something particular also about Sass. You know, it's not really, we're not really, and I'll show you later how to import the data, but essentially you can use any name you want for the variables, especially in this kind of entry. K rate, and then I use tissue K basically for my response variable. Cards is standard, basically indicating that the actual data is coming next. One of the things that's also particular, you see the semicolon after each line. This is very specific for Sass, and I often see that some people have issues and the software is not running well, and oftentimes it's just a semicolon that somebody missed at some point. So pay attention to those details. And don't try not to get frustrated. Oftentimes minor things that we're missing. Things like, again, semicolon. The name of the data is too long. We're not maybe putting the $sign when we are dealing with a text variable. And the way to run this is really to highlight what you want. Is usually the easiest way to do. You can just hit run also here and run the whole thing at once. But I find it easier just to run sections at a time, and you can highlight whatever you want and hit here the submit or the little person running here. Okay. So in this case, and then we go to the log window, which basically tell us whether or not we have any issues. So if everything looks blue or black, that's good. Usually we see red, then that's a problem. Let's try here something without the $sign and see what happens. Start to see problems, right? Invalid data for each of these points, and it's invalid data because it's not a number. Sass is not recognizing this as variable as a number. And yes, it's not a number. It's basically a text that we have here for our location. And so again, putting the $sign, that basically takes care of that issue. Everything clear? Any questions so far? Again, if you have questions, please ask, because it's a way to learn. And we just learned about Sass Studio. I didn't even know about that. Okay, then I have a short code here also using Prog Univariate. And Prog Univariate basically is one way to quickly evaluate for the assumptions for Anova, normality, and so on. So if we run this, One thing also that maybe should show here is that you can clear these just clicking here the white page. So every time you want a clean page to go to the next, is good to use that. Okay, so here's the output from the Prog Univariate, and it's just the general type of summary that you may expect in a basic analysis. And again, some of you in your statistic class already look into that. The number of observation, and this is, I did this basically by location. Okay, so this is location A1. The mean value, standard deviation, all kinds of different types of description of the data, essentially. Okay, test for normality, and again, I'm not going to get into much of these, but there's many ways. Again, the Shapiro wheel, for example, we mentioned earlier, that's one. There are many ways to evaluate for that. Quartiles, how is the data distributed? All of that is from this output. Distribution of the data, tissue potassium. As you can see here, normal quartiles, which looks pretty good. If something is out of this line, then there's some potential issues. Okay, so it's just everything looks fine, but this is one of the first steps if you want to have a better feeling about your data and what it looks like. And Prog Univariate give you that output. Any questions so far on the outputs? Okay. One thing also I wanted to show you here is that I usually, when I run the data, and this is again one way to do it, which is basically essentially copy paste your data in Sass directly into your in the window here. But I usually like to go and see the data that Sass is using for any calculations. And you go to this Explorer, this area here, you go to libraries. There are many folders, okay? And one folder is work. Essentially what we do when we enter the data in Sass is putting this in the temporary folder, which is using basically for all the analysis. And so it's often good to go and check there and make sure the data looks okay. And so in the work folder, here is our data. Remember, we call it all data, and it's right here, okay? So double click, and you can take a quick look at the data that Sass is using for all the analysis. Location looks okay, reps, potassium, tissue, response variable, everything looks good, okay? So I often, I always do that myself because I want to make sure the data looks okay. You can move around, just make sure anything is missing. And this is easy with a simple data set. Now, if you have a big data set, you may have more problems, okay? And so that's the kind of things that you have to pay attention to the data you have before you run any analysis. Because Sass is going to give you an output, right? And the problem is that may not be the correct one. Example, let's run here. Okay, so this is some issues here already, but you see, I just put one more variable there that I didn't include, and essentially what happens is that I added this variable and everything is moved and my data looks bad. And now if I'm going and running the model using TK as a one variable, obviously TK is not here anymore. So you're gonna have all kinds of issues. So again, just make sure the data looks okay before you do anything. Are you able to find this in Sass Studio to get this Explorer?
We have something similar. It just is a tab for output data, and it does the same thing. Additionally, if you took Stat 705 here at K-State, you probably learned about the print procedure, which is what we always use to essentially accomplish the same goal of looking over what was what Sass read as the input to make sure that you have not,
Yeah,
to make sure that
that's-
it's reading properly.
Yeah, that's another way to do it. Again, this is the prog print. Essentially, it's just typing here prog print run, and again you see the data. So that's excellent point. That's one way to do it. I usually like to go and see the file directly. That way, I don't have to put another more code that I don't need. But if Sass Studio will only allow you to do the prog print, then yes, you should do that. Good point. Okay. The other thing I wanted to show you in this case, again, when you have the data entered here, what happens if you have missing data? You have to put space there. That usually, you put a dot here. Okay, so make sure that it's there. If you don't have that, then you're gonna have other problems as well. So again, running this. You see the data now, it has a dot here, okay? If we don't put that space there, then I have issues. And all of this again goes back to making sure, in this case was actually thinking through it. Okay, yeah. Typically we need to put that there. Okay, so any questions on this at this point? And again, this is one way to do it, but I like to move now to importing the data directly from Excel, which is what I will typically do. I usually will not use these unless I have very, very simple analysis that I like to run, and I just don't want to mess with Excel and just copy paste directly here. But this is one way to do it. Any questions so far? Okay. Okay, so I'll stop here and I'll send you another file. Has more code. Okay, you all got that file. Yes. Okay, see a few people. Okay, I'll give you just a minute to upload if you need to do that in Sass Studio. And I already sent you the Excel file as well. So if you put in everything into a folder, that would be the best thing you can do. Just put the different files. Okay. Looks like everybody have the file. You're able to open it. Yes. Okay. Okay. So now basically, again, we'll you have your Excel file. You have the Sass code that I just sent. One feature, and there are many different ways to do import, and I'm not going to try to get into all of them because it's obviously you can spend a lot of time, and you can also find different ways to import, prog import, different type of procedures. One that I like to use is the dynamic data exchange, which is keep things a little bit more simple. And so in this case, this is the DDE command in Sass. the same thing, the file name, which is soybean K, which is in the folder that you already have. This is the name of the file. We are indicating that it's an Excel file. The sheet is number 1 or whatever name you have. And then we basically indicating the range of the data that we're trying to import. So row and column 1 to row and row 65, column 4. Okay, so this is basically the range that we're trying to import. Okay, so this basically this line here, that's what's going to do. One thing about when using this the dynamic data exchange, you have to have your Excel file open and active at the same time. And actually, that's one thing that I like about this, because if I make changes to my Excel, save it, I can just hit this again, and I'm gonna have fresh new data basically coming to my work folder in Sass. And so I think that's a lot of value. If you see some issues, you made some changes to the Excel, just rerun that and you have fresh. Okay, one of the questions, how you modify the code if your data is in another folder? Well, if it is in another folder, it doesn't really matter, because again, what we're calling here is the name of the file. And again, the key here is that we need to have the file open and active. So essentially, Sass is going to use the file that you have open, active with that name at that point. And so this, one of the issues that I see sometimes with this is when you have multiple Excel files open at the same time. That can cause some issues. Okay, and so that's the only issue. I usually tend to just open one Excel at a time, the one that I'm using for my Sass. And if you like, we can look at other options also, which is Prog import and other ways to do it, which again is just more, I feel like it's more complicated. This makes sense? Okay. Okay, so let's highlight this. And now that we have our Excel file open, we have the Sass open here, highlight this first part. In file here and run. Actually, we need to highlight the whole thing because if we the second part is essentially the same thing that we did before, but now we're adding a few other things. In file here, we are indicating the name of the file. We also put in a few other things, like we are saying that the first observation is the row number 2. Okay, so we're not importing this first row. We're starting from the row number 2. Okay, and we can change this if you want. And if you put in more descriptions to your Excel, if you have three rows of description, you can modify this and say the first one number 3 or number 4, whatever you want. You can change these, and then a few other. I can give you more information on what this code means, but most of this is essentially to deal with missing data in particular. If you have one point that is missing in your Excel file, then this is basically gonna fill for complement that. So that's really one of the main points here. Okay, so same thing on input, and this is just similar to what we did before. We get names, and here's a place where you can basically put whatever name you want to your variables. I choose again location, indicating that this is a text rep, replication K rate, and tissue K. Okay. You can also at this point below this, and you can do the same thing in the previous file that I sent you. You can actually create new variables pretty easily. Okay. In this case, I wanted to create one new variable that is called K rate square, which is basically simply the product of K rate. Okay. And you can do whatever calculations you want here. And so again, what's going to happen is that the new data set is going to have a new variable, which is called K rate square. You can also make modifications. And again, this is where similar to, you can do all of this in the previous code that I shared, we looked earlier. For example, you can delete one location if you feel, you know, location number A1, I want to run things without location A1. Then it's just a if then statement here. You can say if location A1, then delete. Okay. Or if rep number 4 has an issue, then if rep equal number 4, then delete as well. You can do that kind of things in addition to creating new variables or deleting parts of the data set. So the other thing also that you obviously see here is that I use the star. When you put the star ahead of a line, that's basically making that line just a general reference. Just Sass basically is going to ignore that command. Okay. Okay, so let's highlight this, run it, see what happens. Okay, here's the data. Now it's bringing this from Excel, and it's actually creating the new variable that just requested earlier. Okay. Again, you can use Prog print for this if you that's easier. Again, if you want to delete some locations, let's say let's delete these two here. We'll run this part again. Look at the data. There's only 2 locations left. Again, A1 and S1 is no longer here. It's all we have. Okay, so you can do all kinds of modifications very easily here. Again, and when it comes to creating new variables, you can do multiply different variables. That's very simple. Just anything you want, you can create new variables here. Let's go back here and get the full data set. Okay. Okay, were you able to do that? I don't see any reactions. I assume you're having issues. Logan, you are a little bit of an expert, so I don't know if you are the, hopefully someone else is also able to do this.
It's working.
It's working. Jean, okay. Good. Amber, okay, thank you. Okay, so and we'll revisit again tomorrow. But any questions on this in this part? Again, this is pretty important because I think give you opportunity to, like I say, create new variables, modify your data before you're even getting to the analysis. Any questions on any of these? Okay. One of the things I always try to include is a Prog sort line, basically is to sort the data. And this is important, especially if you later on, if you're trying to split your analysis by location, for example, okay? And depending on the procedure we are using, some procedures in ProgLink mix can be a little bit tricky with that. Sometimes it's not gonna run very well if the data is not sorted first, okay? And so depending on the type of analysis you do, this may be relevant. And so always good to just go ahead and include it. So in this case, I'm Prog sort data. My name of the data I'm using is all data by location, rep, and potassium rate. Okay, so just run this. Are everything looking good in the log? Prog Univariate, which we already did before, just running again here. This is the same code that I already shared earlier. Okay, one way to look at some of the assumptions. And then we'll get into Prog mix. And I'm just gonna touch on this a little bit and then I'll stop. We already have an hour here today and just wanna make sure we have some questions before we finish today, and then we'll continue tomorrow. Okay, so Prog mix is, like I say, that's, to me, that's really the default for any analysis, because we do have the flexibility to everything. I don't think there's any need to go back to Prog mix or GLM or anything like that. As you can see, the code is Prog is basically how all the procedures in Sass, we call all the Prog. So Prog GLM, Prog mix, indicating the data that we are going to be using. Data equals all data. This analysis in particular, I'm trying to do by location. Okay, so essentially it's going to do a separate analysis for each of the locations we have. And so the next line I have, this is by location. And then my class statement in this line, basically I'm putting the variables that are going to be class state, which basically is not the response variable. Okay, so that could be all the fixed or random factors needs to be here. Okay, but it's basically has to be the class, all the class variables. So what we have here is after we already put locations here, we're going to do the analysis by location. We have reps and we have K rate. Okay, so if you go back to your data, again, we have different class here, locations, replications, potassium rate, right? And so right here in these two lines, we're covering all of those three. And then the model, which is the next line, basically what we are indicating here is the response variable, in this case, the tissue K, which is what we're using. And the fixed effect is what's gonna go here, okay, which is the potassium rate, which is our treatment, okay? In this case, it's gonna be only the fixed effect. Now, if we have a factorial experiment, for example, if we have K rate by nitrogen rate, in that case, then we're gonna put by N rate, okay? And obviously, N rate will also become a class variable, right? That's gonna be a more factorial experiment, for example. Obviously, that's not what we have here, but we can explore that also later if you like. But in this case, very simple. The fixed effect is potassium rate, and then we do have the next line here is the random. In this line, we are indicating what variable is the random factor in our data set. And in this case, I'm indicating the rep or block, whatever you want to call it, is the random factor. Okay. And so that's basically the basic things that you need to be able to run. Again, obviously, at the end, you always have to put run, semicolon, and that's basically ready to go. So that would be the very basic components. Before we go there, one thing that I always like to include, and I think this is kind of the main things we want, is the LS means, which basically give you the LS mean values of the treatment factors. In this case, the K rate, which is our main fixed effect. One of the options that we have is lines, which I like this because it's the option that gives us the output for separation of means using letters. So if you're seeing your Anova table, you see these A, B, C, different letters. Lines is basically going to give you that. And the default is going to be alpha of 0.05. If you don't put anything else here, the default is going to be 0.05, but you can obviously modify that. You can point a different alpha, and that's also going to give you output for confidence intervals. So let's highlight this and run it. Okay, so again, this is by location, so we're going to have a long output here for location A1. There's a lot of information about the model that we're using, okay? The name of the data set, the response variable, which is tissue K. what kind of distribution, which is a Gaussian distribution, is a normal distributed data. If we decide to include a different type of distribution, it's going to show in here. Okay, we use a log normal or any type of other distribution, it's gonna show there. The estimation technique, the default is also restricted maximum likelihood, which is I don't know if some of you look into in statistics into this, but there's really a few different ways to for estimations, and the default is restricted maximum likelihood. This is something that we can also change. If you use Prog GLM, again, it's not gonna use it's gonna use a different technique as well. The class levels that we have reps. We have 4 replications. These are the values. We have potassium rates, 4 levels. These are the values again. So just give you, again, it's always good to take a look at this just to see is this making sense with the data that you are analyzing, making sure there's nothing strange there. There are a few other things, you know, number of observations that that we read, a few some information on the variance covariance matrix, optimization information. Some of these, I don't know that we need to get into it, but and this is the question that we have earlier about fit statistics, and here's where we can compare different models. Okay, the archaic information criterion is one that maybe is the most common one. Okay, and so smaller is better. So if you're trying to compare 2 different models, make modification to your models, and you want to compare them, this is one way to do it. Okay, so it's a more pure statistical way to compare models, which again, in many cases, will have a lot of value, especially if you're getting into more different model evaluations and that type of things. Typically, my approach is that, you know, if I analyze my data the way it was designed, which again, really no changes there, there's really not a lot of need to start looking into this, because obviously we are analyzing the data the way we designed the experiment, which again, whether it's a randomized complete block or whatever design we use. This is the estimates of the variance here. So again, obviously, what variance is coming from the reps, what's coming from the residual error. And those are just give you an indication of the source of variability, essentially. And here's where we get with we were really interested, usually, which is the p-values of the fixed effect. In this case, the treatment, the effect that we're looking at is potassium rate, and this is the p-value. Okay, and in this case, the p-value that we have is a 0.23. Okay, so if we're using 0.05, we're going to say the effect of treatment in this particular location, which is what we're looking at here, location A1, is not statistically significant. Okay, so this is one key output that we tend to look at. And I'm not going to get into the discussion. I think I visited with a few of you in the there's a lot of discussion now about the value of using p-values, whether we should be using p-values at all or not. But in reality, I feel like we're still using a lot p-values to be able to see what's significant in terms of treatment effects, and that's one of the things I like about SAS, that we're still getting this as one way to evaluate whether a treatment is significant or not. The next output here, which is coming from the least square means, and this is specifically output already that's coming from this line here, okay, LS means. If we're not putting this line, then we're not going to get that particular table. And so in this case, the information we are getting is, again, the treatments, the different rates, and the estimate, which is the LS mean values. This essentially would be the mean value, but in reality is the LS means. Okay, so if we are putting together a graph or a table with the mean values for each of the treatments, this is the number that we need to be looking at. Okay, this is the table. We have the standard error. If we want to put error bars to our graph, then we can use these standard error values. These p-values oftentimes is confusing, but these p-values, all it's telling you is that the actual estimate is statistically significant from 0. Okay, so it's really it's has no value for what we typically use. The estimate standard error is typically the main thing we're looking at. And then the other table that I have here is basically what's coming from the lines command option that we have here. And it's basically using, again, alpha 0.05 and basically grouping the data using the letters here, okay? And as we know, this is not statistically significant at 0.05. So as you can expect, we have letter A's for everything. Okay. If we look at other locations, just quickly to see, we have a little bit different results. Okay, going back to the fixed effect p-values, this is 0.02. So again, this is statistically significant at this location, which is the location 02. Okay, and as you can expect, obviously the table with the separation, letter separation, has basically two groups in this case. Basically what we're seeing here is that the rates of 112 and 168 are statistically different from the control. Okay, so again, this is often what we tend to see still very commonly used, and I feel like that's still perhaps one of the most common ways to present data in most of our studies in agronomy. Questions so far on this? And I think I'd like to stop there today, and we'll discuss more tomorrow on the outputs. But please ask questions if you have now, and we can discuss a little bit today and maybe continue tomorrow as well.
I have a question.
Yes.
So for particular me, so when I'm using Sass and I have an LS mean statement, and the estimate that Sass gives me on my LS mean statement is slightly different than what I get when I average everything out in Excel. And I know that has to do, I think, with the errors and everything, but when I present this data and when I'm making the graphs and determining the significance, which estimate am I supposed to use? Yeah,
that's an excellent point. And that's often what happens, because the way, and that's why I mentioned earlier, this is not really the average, the way we calculate in Excel, or if you just do a calculation by hand or something like that. This is the LS means. And so in the case of the LS means, and it's going to be particularly different if you have, for example, unbalanced design, or if you have missing values. If you have a perfect data set, the LS means and the means that you calculate in Excel should be exactly the same. Mm-hmm. Okay. And do you have any missing data or anything like that?
Yes.
Okay. Yeah, and so that's exactly what happened. And essentially LS means what's doing is trying to give the same weight to all the treatments. And mm-hmm. I'll show an example tomorrow, because I think this is very important, the difference between means and LS means. Because in reality, it's not fair if you're comparing two treatments. One has 4 values and the other one only have 3 values, right? Mm-hmm. And so that's the problem there. And again, I'll show one particular example tomorrow when we begin. But basically, LS mean is essentially trying to take care of that issue with missing values. And so your second question is, what should I use? I will definitely use LS means. Okay. Especially with missing data. And again, that's one of the strengths, I think, from using this approach, because again, the regular mean can be misleading, especially with missing data.
All right, thank you.
Yes, and I'll show one example tomorrow. Other questions?
I've got a question that kind of ties into that a little bit, Professor Dorbar. So I noticed does this automatically use a type 3 sum of squares?
We can use different types of analysis, and again, we can get into that as well tomorrow. And again, this is where we have a lot of flexibility with CleanMix. And I just want to make sure we're not, just want to make sure we're getting everybody at the same level at this point. But yes, we can, this is the default, but we can use different types of analysis, right? And so I'll maybe show one example tomorrow as well, just to show that. The other thing too is that I mentioned earlier is that the type of estimation that we're using is restricted maximum likelihood by default. This is something that we can also change in GleanMix. And again, that's the advantage of GleanMix, is that we can basically modify, make changes to do something identical to Prog GLM, or we can do something more advanced. So it gives us a lot more flexibility. Good questions. Okay, another question. How is the experimental design will affect the model? And yes, and this is where, again, I mentioned earlier a little bit, what if we have a factorial, complete factorial experiment? In this case, we're going to have interactions, for example, right? In this particular data that I showed, there's no interaction. We don't have any factorial component, but again, we can easily, how is that going to change? Let's assume that you have a data set that has complete factorial of different potassium rates and nitrogen rates, okay? And so this again goes back, in this case, we're going to have another variable, which is going to be N rate, and so we need to include that in the class. Now we're going to have essentially an interaction here, and there's a couple ways to include these. You can put N rate, and you can put the interaction of these two factors. Okay, so now your model is growing here. Instead of doing all of these, what I usually do in Sass is I just use this symbol, and I don't know what this symbol is called, but it's just a little line. Again, I don't know, some of you may know the name of this symbol, but this basically what Sass is going to do is going to look at both K rate independently, potassium rate, and the interaction of potassium and nitrogen rates. Okay, so obviously we need to look at that interaction because we do have a full factorial experiment. We can also look into one example like that. And actually, if you have, Sachin, if you have one example of your data, we can do that maybe tomorrow as well. But again, this is where we have flexibility in terms of how we modify the model within Sass. And we need to, that's going to change depending on each of your experiment, of course. Any other questions?
Does that, so if you had maybe another random, or maybe another variable that you wanted to include as a random effect, like year, maybe, or something like that, would that be kind of similar?
Yes, and actually that's the next line that I have here, and we can get into that tomorrow. But in this second set of codes that I have here, I have still classes location. I'm trying to include location also as a random effect. So now I'm going to have reps, and I'm going to have location as a random. And so in this case, what I do is, you see, the analysis is no longer by location, but location becomes part of the model in this case. And so we are including location in the class statement. And so we have location, replication, and potassium rate. The model is still the fixed treatment, still potassium rate, okay, response variable here. Now in the random line, this is where things change. And what I have here is replications within location. Okay, so each of the replications within each of the locations, those components are random factors. Okay, and again, everything else here looks the same. I added something else here in terms of the alpha, but otherwise everything looks the same here. So yes, you can start to move in your variables, whether it's random, fixed, in making changes to your model as well. I'm not going to run this today. I'll like to do that tomorrow. See if you have any other questions or anything that you'd like to expand tomorrow. Okay, so So tomorrow we'll get more into these and also some graphs and some basic outputs there for especially for LS means and interpreting the outputs. In the meantime, before we meet again tomorrow, I'd like to, if you have any other questions or if you did have some issues today with running the code or anything, send me an email, please. And make sure we clear everything up tomorrow before we start. And again, we'll explore more some of these questions, the concept of LS means, types of model, and so on tomorrow. And especially trying to understand the output. I think this is prepare questions also for tomorrow. As you look at this output, make sure you understand everything you're seeing there and if there's any questions, okay? Okay, Josefina, what do you think? We stop there for today and continue tomorrow?
Yeah, I think that works. So we'll see you all tomorrow back again at 5, just like today. And yeah, think of some questions if you have them from today, and then tomorrow is gonna be, I think, the most interesting part with the digging deeper into the models, I guess.
Yes, and actually, again, if you have some of your data that you're like willing to share that maybe is a little bit more complex, more issues, if you send it to me early enough, I may be able to put it together before we meet in the afternoon. And so please do that. We can maybe work on your data tomorrow.
Okay. Thank you very much, Dr. Ruiz Diaz. And yeah, we'll see you all tomorrow.
Okay. Thank you all. See you tomorrow.